Welcome to Mr. Dady's Neighborhood. Today we are talking about the scientific method. The first thing in the scientific method is choose or recognize a problem. Here in Mr. Dady's Neighborhood, we are having problems with the lights. They keep going on and off. We can't figure it out. So all we have here in Mr. Dady's Neighborhood today is some pickles, wires, nails, and some cups. Based on the stuff we have, since we've recognized our problem of needing a new light because the lights aren't very good around here, we need to research this problem. So with the stuff we have here, we would look up stuff like the conductivity of the nails. Because if the nails don't conduct electricity at all, what's the point? Will the pickles light up? We don't know. Why did they light up? Stuff like that. Anything to make your point stronger and figure out a better background for the information is what you need to do with research a problem. The next step is develop a hypothesis. Now, I'm going to get Mrs. Dady, who you saw briefly in the other video, to come in and explain independent, dependent variables and the hypothesis.
All right, so I'm going to talk about developing a hypothesis. A hypothesis is basically an educated guess. So you've already done your research, so you have some background knowledge of it. When you develop a hypothesis, you want to have an independent variable, which is what you change, it's what you put in to the experiment. It's also called your manipulative variable. So something you change, like in kindergarten, in elementary school, you played with manipulatives, something you change. You also want to have a dependent variable. That is what changes because of what you changed. So in this case, when we're looking at the pickles, we are changing ourselves, we are changing our nail length. And what is changing because of that is the dependent variable, or it's also called a responding variable, and that's the time it takes for it to light up. And those are things that we're measuring. When we develop our hypothesis, we always want to go if the independent, then the dependent. So if I study a lot, that's my independent, then I will get good grades. The grade number is my dependent. That's what changed because of me studying. We always want to make sure our hypothesis is testable. I can't do something that I can't test. If I'm not on Mars, I can't test it. Right now, you probably can in a couple of years, but not right now. You also want to make sure that it is falsifiable. And falsifiable means that I can prove it to be wrong. I can't prove that something on Saturn is wrong when I can't test it. So these two things go hand in hand. So if I were to say, Bigfoot lives on Earth, okay, yeah, Bigfoot lives on Earth, that's just a blanket statement. It doesn't really say, is it false or is it not? So now Mr. Dady is going to go back and talk about collecting data and doing your experiment. But before he does that, let me talk about designing an experiment. When you design your experiment, you need to be as specific as possible. So step 1, step 2, step 3, and you need to make sure that you use quantities that are specific. Don't say, get a pickle. Well, how long is a pickle? Don't say, get a nail. You need to tell me how long the nail is. So make sure you're being specific and make sure you are using metrics. Y'all did this in science fair last year, so it shouldn't be that hard.
So now that Mrs. Dady has explained what an independent and dependent variable is, we are going to design an experiment. Next step. And after that, we're going to actually do the experiment. So the first one we're going to do this twice. The pickles are 11 centimeters each, and we have 2 sets of nails. One set of nails is 4 centimeters, and the other is 6.5 centimeters. And we're going to see which one lights up faster. All right, so please do not try this at home at all. This is a very dangerous experiment. Be careful. Do not try it at home at all. So we're going to take the pickle, we're going to take the nails, and we're going to plug it into each side of it. Like so. All right? Again, do not try this at home. It is very dangerous. Now I'm going to go turn off the light. We're going to plug in our pickle to see if it lights up. As you can see, the pickle is lighting up. It took about 6 seconds. Now I have an actual timer in the back, and they're going to let us know the exact time in a minute. But as you can see, it's lighting up. You can see the smoke coming off of it. You can't smell it, but it's got a very horrible smell right now. We'll talk about this later when it comes to energy transformations later in the year. Alright, so I'm gonna unplug it. I'm gonna take my nails out. Now I'm gonna unplug it like that. Take my pickle. And now, very carefully, I'm going to remove the nails. This is experiment 2. It's the same size pickle at 11 centimeters, but the nails we're using this time are 6.5 centimeters. Let's see if it makes a difference in the timing. So I'm gonna plug it in. And there it goes. Again, it's lighting up, creating the smoke it needs. So now I'm going to unplug it again, take my nails out, and that concludes both of our experiments. Now we just have to look at the time for both of them and see and collect our data. Now the experiment's over, our next step is to organize our data. So this is when you'll take your time that you took, the size of the nails, and if you want to do this more times, you could to prove your point. The more tests you do, the better it is, because one of the pickles might have been sitting out of the liquid and it changed it a little bit. It might not have been as wide. There's a lot of stuff that can change. But we kept it as close as possible to it. So we're going to organize our data now so that we can look at it. The next is draw a conclusion. From that data, you're going to look at it and give a reasonable idea of what you think. Now, from just watching it, you can probably tell which nail is better. But to have that backing of the actual test data makes your conclusion much, much stronger. So that is why you have to organize your data correctly and then get your conclusion. And that, as you can see, is the circle of the scientific method. Now, if you don't get it the first time, you can do the whole process over. If your data is skewed somewhere, you can do it all over. As you can see, it doesn't take very long, and it will make everything better.